If we consider our previous class, we managed to work with the equivalent values, which is important. And from those equivalent values, we are going to actually have a continuation that is calculating this time the regulation, which is the voltage regulation of a transformer using equivalent values from those equivalent values that we had. So the percentage regulation can be calculated. Let's say we are given, it will be of the information that you are given. So given information or data that is of the primary side, referring to the primary side of the primary, referring side. So let's say you're considering that it is the primary referring side that you have where you have got the current one, and you're going to talk of the equivalent resistance. You're going to talk of the equivalent reactance, and definitely from the primary side, you'll be having V1. Having phi as the angle that is given, which can depend to be the angle of lead or angle of lag. We can calculate our percentage regulation from this information, whereby our percentage regulation can be given from the formula I1 into, that's going to be equivalent resistance of the primary side. So you're going to have cos phi plus or minus, we're going to have the reactance primary, then we're going to have sine phi. So this is the formula that we are going to actually have everything that we are seeing over 1. Then as a percentage, that is, we're going to multiply by 100%. Remember the relationship that we had. It means for you to obtain per unit regulation, it is simply the percentage regulation that you'll be having, you divide it by what? By 100. Meaning, say whatever that you're having, if you divide it by 100, if you remove 100% here, if you remove this 100% like this, what are you calculating? You're calculating per unit regulation if 100% is not there. The moment you multiply by 100% like this, it means you are now having what? Percentage regulation. So that is the relationship, guys. So on the plus and minus is going to depend. The plus is going to be for the lagging power factor. You can be given a lagging power factor. That's going to be a negative. That's a lagging power factor. When you have got this negative, the negative that we are seeing there, it is when you are referring to a leading power factor. When you're given a leading power factor, that is what you must use. So this is the formula, guys. As you can see, we talked about this. If you still remember from our previous case, let us go back here. When I referred about these equivalent values as referred to the primary side, as referred to the secondary side, you can calculate from these formulas. When it is provided that they are from these formulas, we can also have these equivalent resistance, equivalent reactances when we are given percentage equivalent reactance. This is, remember I said, guys, we've got a lot of things. I just hope you understand me in the explanations. From the percentage impedance, you can obtain per unit impedance, which gives you per unit resistance, per unit reactance. Okay? And these per unit resistance, per unit reactance that we are seeing, remember how were they calculated here using these formulas that I explained about per unit values. If you want to write them as percentages, this and that. Per unit resistance. And inside of per unit inside of the formula, inside of it, we can see that the equivalent resistance is hidden there. Equivalent resistance is hidden there. The equivalent reactance is hidden from per unit reactance. Also, on the secondary side, it's hidden. So as we do need these values of the equivalent reactance, equivalent, resistance. We must not only think of these formulas here that I talked about. We must not only think along those formulas, but we must think along also where these are obtained. Where are they in any formula? Where are they? Because in that formula, you can go back and transpose and make them the subject of the formula. After calculating them, you use them on this formula to calculate your percentage regulation or per unit regulation, which is simply percentage regulation over what? Over 100%. So guys, you must be careful. This is mathematics. So no longer just electrotechnics. They are not mathematics. Manipulating change of subject, go back and look for that. Where is it? So this must be careful. If it was on the secondary side, if you are given the information of the secondary side, meaning to say you're going to referring to I2, we're going to be talking of I2, and on that case, the resistance will be equivalent resistance of 2, equivalent reactance to voltage. Those are the ones that you'll be using. You can also calculate that. Percentage regulation is going to be the same. So it's going to be I1. That's I2 this time. So this is another way that you can also calculate it, provided that these values are given or you've calculated them. So you're going to use, instead, this will be RE2 cos phi, just because we use the phi, but it is the same. So other textbook, they can write this as phi 2 plus or minus x E2. Then it's going to be sine phi 2. I'm going to explain about this one because you might be using another textbook and it is just using or writing this as phi there. It is one and the same thing. The phi 2 is the angle that you are using when it is of that part that you're just considering. It's the same as this one. That angle that you're given on that question is the one that you use there. You use the angle that you're given. Okay? From cos, remember from cos, you can determine the angle. Maybe you're not given the angle because not always that you'll be given the angle. Remember cos of theta from the cos of phi, it represents our power factor. So the phi, which is the angle that we need, it will be arc cos of the power factor that you arc cos of that. You have the angle. Then you can determine the sine of that. So the two there is not even important. It is just showing that we are dealing with, like, we are considering the secondary side, but that too is not even important. Do not even mind about that. Okay. But the plus or minus is still there. The lagging, leading, plus, lagging. This one is not going to change. Minus, leading. Only that you are working with the secondary referring values, those ones that we had. So this is what you're going to have as your power factor. I mean, as the percentage regulation formula. And from this formula, you're going to see questions, like I was saying, how to remove from percentage to per unit regulation, divide by 100%. Okay. Percentage regulation can also be obtained given percentage values. Okay. We can obtain from percentage resistance and percentage reactances. How can we calculate from these? How can we calculate the same percentage regulation? So it follows that the percentage regulation can be calculated as, so for a lagging, let's start with a lagging. As we said, lagging carries a plus. So it's just, or let me just write one formula as it is. So it's going to be percentage resistance plus or minus, take note, plus or minus the percentage of the reactants. Okay, so we've got cos there. Remember resistance, cos, first part with what? Cos. So it's going to be cos of phi plus or minus percentage reactance, the sign of what? The sign of phi. So this is what I want you to have, the plus still, guys, for the lagging. power factor. This one for the what? Leading as it was before. So if you're to consider they are percentage resistances, reactances that you are talking about there. Remember when you had impedance before, we talked of percentage resistance, percentage reactance. As they are, they can be used now to calculate a percentage regulation. There is no J there. There's no J. You just combine. Your answer is going to be a percentage. You get the as it is. So we're going to see formulas. We're going to see like questions applying this. And from this is due to the regulation. Remember percentage. This is the voltage regulation. So therefore, as it has affected the voltage, we are going to end up with a new voltage after the regulation procedure. We can talk of the secondary terminal voltage on load. How to calculate the secondary voltage. Okay, the secondary, which is the terminal voltage. Actually, we talk of the terminal voltage on load. Meaning to say we are talking about what? At full load. At full load. How can we now obtain the secondary terminal voltage? This is the new voltage. So I'm just going to write it as V2 new so that we can understand, because guys, there's a lot of things that we can actually have there. So let me just write as V2 new. So I'm going to write as V2 new, which is the new voltage, can be obtained from the original that we obtained, that we had before, V2 original, terminal of that, the one that you're given from your information, okay, into 1 minus per unit. Take note, per unit regulation, not percentage regulation. Per unit regulation. Guys, understand the difference. Percentage regulation is a percentage. So it follows that per unit regulation, it is simply the percentage regulation that we had divided by what? Divided by 100. Okay? Divided by 100. You have to divide by 100%. So you divide by 100. That is per unit regulation, this one. That's a decimal of a percentage. The decimal of the percentage. The decimal. Whenever I talk about the decimal of a percentage, that is when you divide it by 100. So you must be careful. So due to the calculations, your per unit regulation, from that percentage regulation, it can be a positive, it can be a negative. So do not worry there. Just use the values as they are. A positive, use it as it is. A negative, use as it is. You are going to notice that that is the V2 is the original. We are talking about at open circuit conditions at no load. But V2 new, that is at on load when it is now a closed circuit. You will notice that the voltage that you are referring as the new voltage at the terminal of the secondary can be related in two means compared to the original voltage, that it can be greater than the original voltage, the one that we had. In that case, it means you are dealing with a leading power factor. It can be a condition that the V2 new that we just calculated right now is less than the original V2. In that case, you are dealing with a lagging power factor. The power factor that you're dealing with, there is a lagging one. It is supposed to be very, very careful about that, because somehow they will give us information where we are just given V2 new and they want you now to relate it from that one. You see, these guys, they know that we are now used to this. That is why the change of the introduction of the new syllabus, this and that. They know you are used to these formulas. They want to interchange here and there. So meaning to say, as they see that, okay, we are now used to all these formulas, they'll also come to this relating from that, creating questions from this relationship, where if you don't understand that relationship, you won't be able to answer anything. So you must be careful in your understanding as you are revising. So this is it about our percentage regulation. The most important part are these are follow-ups after you've calculated your percentage regulation. These are follow-ups things that you need. But as you consider what is percentage regulation, this is the part that we need. Considering that we calculated it using the information of the primary, or we calculated it using the information that we had from the secondary part. So with this information, I need us to have a question to relate to what we just had. In this question, we are given the percentage impedance. Take note. The percentage impedance of a what? Okay, let's talk about this before we talk of the percentage. This is input, output, like secondary, primary, and what secondary. So the voltage, 1100 V1 and V2. Okay, so let's just have our data there. We are given V1, 1001, it's 1100 volts, and V2, it was 240 volts. But the question is saying the percentage, this is the most important part, the percentage what? Impedance is the one that we are given of a single phase. It's a single phase transformer. Is, take note, this is our percentage. They are not giving us just a normal impedance. It's a percentage. So this is, okay, let's take our percentage impedance. Our percentage impedance is given as 4 plus J 9.5%. This is what we have, guys. And if the transformer draws a current of 30 amps from the supply, which is the current that we have from the supply I1, if this transformer draws that current of 30 amps from this information, they're now saying determine or calculate the equivalent resistance, leakage, the equivalent, and impede, referred to the what? Referred to the secondary side, referred to the secondary side, meaning to say they want you to have the equivalent resistance, secondary side, the leakage reactance equivalent of it, secondary side, and also the ZE to of the secondary referred to the secondary side, which is fine. It's not that. But the question is, guys, let's go back to the impedance, because with this information here, guys, we are going to be stuck. Okay, let's go back to our formulas. I talked about that here on our introduction. If you check here, you're going to be stuck if you think of using these, because it's okay, these are the cases that we had when we talked about method of referring. So what can I do from this to have? No, because we do not have R2, these R1. These ones can be used when you have got those values R2, X2, the reactances. So the only other part that we are left with that I was explaining before is here. From per unit resistance, per unit reactance. Resistances and reactances of the equivalent are hidden. Secondary side, they are hidden here. RE2 and XE2, they are hidden here. So meaning to say, if someone has a per unit resistance and a per unit reactance, that person can use it to calculate these values. But what is per unit resistance? Remember, per unit resistance, it's a value that was obtained from percentage resistance. You just divided by 100%. So that's why they are giving you here as a percent. You must be careful, guys. Once impedance is a percentage like this, it means this resistance, it's not a normal, this is not R there where we say R, it's 4 ohms. No. It's a percentage there. This one, it's a percentage resistance. Remember your formula for percentage Z. It was made up of what? Percentage R plus J percentage X. So this is a percentage and this is also a percentage of X. So if this is percentage resistance, this one, if this is percentage resistance that we are given as 4%, what about per unit resistance? From percentage, you divide. So you divide by 100. So it was going to be 0.04. If truly that this is percentage reactance that we are given there, which is 9.5%, what about the per unit reactance of it? You divide. So that's 0.095 by 100. Going to be 0.095 like this. We are having per unit values, per unit resistance, per unit reactance. Why are you talking about this? Because we saw that there is a part that we saw that carries these ones together with the equivalent resistance, equivalent reactance. So let's manipulate and make RE the subject, XE the subject of the secondary side is referred to the secondary. Okay, so as we saw that so they were already answering. So this is A. Okay, so that is going to be A. So since we want to calculate, remember, we want to calculate these two, RE2, XE2, and what? And ZE2 of the secondary side. So from per unit resistance, which states that per unit resistance, remember your formula? If you're considering the primary is I1, RE1 over what? Over V1, which is equal of the secondary, it's I2, RE2 over V2. This is per unit. I talked about these formulas, guys, on our introduction. So we're not considering the primary, we are considering the secondary. So we're going to take this one off the secondary side. This is the formula that we are supposed to have per that unit resistance. It was supposed to be taken as what? I2 RE2 over what? Over V2. And we can see that RE2 is there. So let's make it the subject. Okay, this is over 1. So let's make this the subject, cross multiply. That's going to be what? 1 times this. We are going to have I2, RE2, which is equal to, if you cross multiply, we are going to have per unit resistance times what? Times V2. So I need this one. So I'm going to divide by I2 both sides. Simply divide by I2 both sides. So that was going to give us the value of the equivalent resistance as referred to the secondary side, which is per unit resistance as it is 0.04 times V2, which we have as 240 over what? I2. But the question, are we having I2? We are stuck again because we do not have that. We just given I1. So in order for you to have I2, you are now forced to calculate this. So let's find I2 here. So to find I2, we can think along the transformer ratio. Remember your transformer ratio, the relationship between voltages, currents, that's N1 over N2 is equal to V1 over V2, which is equal to I2 over I1. But there we do not have the number of turns. We have got the voltage. So we're going to consider this. We can find I2, this one. So how can we make I2 the subject? We need to remove I1. So we can multiply by I1 both sides. Multiply by I1 both sides. So meaning to say this will cancel. The moment you multiply by I1 both sides, this will cancel. You have what? You have I2 there that is remaining. So I2 is equal to I1, which is given, that is 30 times V1 over V2. V1 over V2, that is 1,100 over V2 240. So we're back to mathematics. So that's it. We've got our current 2. And this was going to give us 137.5 amps as our I2. Where is it that we need this I2? Remember, it is the one that is missing here in order for us to find equivalent resistance. So now we are just simply going to substitute, okay, the I2 that we calculated, this one. So this is 137.5 amps. So that was going to give us the equivalent resistance of 0.07 ohms, considering secondary side. So we've got our RE2. So like I said, we'll need these ones to calculate our percentage regulation. So let's just write these ones aside. RE2 is 0.07. All right, so let's just write it aside. This is 0.07 ohms. We have got the equivalent. Okay, so also I2, you do not, you're gonna need this because remember you're dealing with the secondary side. So definitely we are going to need I2, which is 137.5 amps. So we're gonna need this value. All right, let's check the other part, which is still on this. We need, we calculated this. So now we need E2, which is the reactance. Considering the reactance, again, we saw that from our per unit reactance, because this is reactance equivalent from our per unit reactance. How were you calculating this? Per unit reactance can be considered on the secondary, because we're dealing with secondary side, I2, XE2 over what? Over V2. If it is primary side, I1, 1, 1. Okay, talked about these formulas, guys. We still remember? That's per unit reactance. But what is that unit? We need this one. So you're going to do the same thing, make it the subject of the formula, the one that you want. So you're going to make it the subject. So this is the same as over 1, guys. Cross multiply, just like the previous case. That's 1 times this. So we're going to have I2, X E2 is equal to, if you multiply these two, that's per unit reactance times V2. So we need this, remember? So what are you going to do? Simply divide by I2. So you're going to divide by I2 both sides. So we now have our XE2, which is the equivalent reactance as referred to the secondary. Per unit reactance is the one that we have here. Remember, that's why we're dealing with this formula. 0.095 times V2, or V2 is not going to change. That's 240 over I2. I2 also is not going to change. That's 137.5, the one that we calculated above. So that's it. We're going to have our equivalent reactance as referred to the secondary side, which is 0.166 ohms. So that's the condition. We have got this. Okay, so let's just write it aside. That's 0.166 ohms. Then also they need you to calculate equivalent impedance as referred to the secondary side. That's 2 then. I talked about this in the introduction, that as you are to deal with the equivalent impedance, you can use the 2 formulas, the direct formula where you can consider the square root of RE2 squared. But guys, in whatever calculation that you have, that angle might be needed. So it'll be best that you have this in what? In J notation. Then you convert your polar form. So in J notation, remember the equivalent impedance is going to be from RE2 plus JX E2. We're talking of the secondary side as referred to the secondary. So that's it. Our RE2, that's 0.07 plus our JXE2, which is 0.166. So with this, you can also write it in polar form, because you do not know, guys, what's going to happen next where we need these values. So to polar form, we talked about this, guys, that's shift to polar form, press the plus, that's 0.07. To separate this, it's going to be shift close bracket, that's 0.166. So after this, you can write your answer as you do understand in polar form. You need R and angle theta. So R is given as what? 0.180. The one's not going to change anything. So that's 0.18 at an angle theta. Using the theta, that's 67.135. Okay, that's 67.135 degrees. So this is it, guys, about our equivalent impedance from what we obtained as our equivalent resistance and reactance. We can have it like that, which is fine. So you must be careful, like I said, in these calculations. Let me just remove this part, guys, so that not gonna we have got a lot of things. There it was because you are using the values of the secondary side. So you relate to the secondary. Sometimes in an exam, you are given that of the primary side. You calculate using same per unit resistance, considering what is on the primary or what is referred to the primary side. Then from there, they want you to calculate the percentage regulation of the transformer if it supplies a load operating at a power factor of 0.8 lagging. Okay, that's our B. So we need to calculate percentage regulation at what? 0.8 lagging, at a power factor of 0.8 lagging. Percentage regulation. This is the major part of our class, remember. And I said percentage regulation can be calculated from this formula. We calculated, in this case, we are using values of the secondary side. So you're going to use this formula where you've got I2, these values of the secondary side. Remember, you're dealing with the secondary side. That's a 2 there. So you must work with the secondary side. Or the percentage regulation if I have percentage resistance and the percentage reactance. Percentage regulation can be calculated. We saw that because there is percentage resistance and there is also percentage reactance. So there are two formulas that you can actually use there. Okay, let's start with the first one that I explained, which is the basic, the formula that we wrote so that we understand our formula. Our formula is stating that the percentage regulation is going to be given as, since you're dealing with information that we calculated from the secondary side, you're supposed to think of that. So you're going to use the formula of that information of the secondary side, RE of the secondary side, that is going to be cos phi. Like I said, you can use phi too, depending on the textbook. They are saying it's a lagging, and I said lagging, it's a plus. Wherever a lagging is, that is where you use the plus. The leading, a minus. So you're going to use a plus because it's what? It's lagging. So this is our formula as it is because we're dealing with a lagging. So that's going to be a plus xe2. Then we're going to have the sine of phi, everything over what? Since we're dealing the secondary side, so you divide by the voltage of the secondary side times 100%. You need percentage, so you must multiply by 100%. But the question is, we have got all these I2 is given, calculated this, we actually calculated, remember, RE2, we calculated this, XE, we calculated, V2, we are given. Cos phi is our power factor, remember, power factor represents cos phi, so it's there. That's our power factor, but we do not have the sine of phi. So to find the sine of phi, we're going to determine first the angle so that we can determine the sine of that angle. From where? From the cos. Remember, cos phi represents the power factor. So if cos phi represents the power factor of 0.8, what about the angle phi? So phi is going to be arc cos 0,8, meaning to say our phi is going to be arc cos 0,8. So this is it. I'm going to show you on a calculator so that also you obtain exact values. So you do it like this. Arc cos, it's shift cos. That's shift cos 0,8 like this. Close it. That will be this decimal. That is your angle, 36,87, whatever that you're having there. But this is what you want. You need the sine of this angle. Remember, this is your phi. So you just find the sine of the answer so that you get exact values. So sine of the answer as a decimal, that's 0,6. So it means the sine of phi in this case is equal to what? 0,6 from the angle that you have. But just use sine answer, guys, so that you have what? Exact angle. Exact values there. So these are the two things that you need. The cos phi, it's already there. This is our power factor. The plus, remember, a lagging power factor. So with this, we can substitute and calculate your percentage regulation, just like that. So our percentage regulation, I2, we calculated this. That was 137,5. So you're going to have 137,5 into RE2. We calculated all these values, our RE. If you still remember here, when you calculated, that was 0,07. 0,07 times the cos of phi, which is 0,8. Cos of phi is 0,8 plus xe2. We calculated this. It was 0,166 times the sine of phi. We also have this. Substitute 0,6. Everything over what? Over V2 secondary voltage, which is 240. Just like that. So this multiplied by 100% gives you a percentage. If they wanted just a per unit value, you are going to leave this 100%. But they want a percentage, so you must multiply by 100%. So this is what you are going to have, guys, as your percentage regulation. Just make sure you use your calculator properly. You are going to obtain 8,915 percent as a percentage. But remember, I talked about the two formulas that could have been used for the same percentage regulation from the percentage resistance and the percentage reactance. We can calculate what? The percentage regulation from this formula. So a lagging power factor, we're going to use what? A plus. So using this formula, it is stating that percentage regulation, let's see how it was just going to be like from that. So using this formula, we can see that it is stating that percentage regulation can be calculated from percentage resistance. That is going to be cos of phi in this case, plus, because it's a lagging power factor, so you're going to use a plus. So you're going to have percentage reactance, then this will be the sine of what? The sine of phi. So this is what you're going to have. This is what you have. So using this formula, definitely you are being forced to calculate this, the sine of phi. This one, there's no way you're going to be forced to calculate this. After that, you can now substitute. But what is it that you're substituting? These are percentage values. So we're going to have percentage regulation as percentage resistance. What is the resistance percentage? Not per unit, but percentage. Percentage resistance is what? It's 4%. We multiply that. So it's 4% times what? Cos phi, which is our power factor. Remember, our power factor was 0,8 plus percentage reactance. Again, on your reactance, what is the percentage? 9,5. So that is going to be 9,5, our percentage reactance, as a percentage times sine of phi. Remember, our sine, it was 0,6. This is a percentage. Whatever that is here, these are percentages. So your answer is automatically as a percentage. So it was going to give us 8,9%. That is the condition. That's another way. So under exam condition, if just calculate percentage regulation, guys, if these values are there, you can opt for that easier path. Unless if you do not have those values of the percentages now where you need to calculate them first, you end up seeing that it will be just the easier for you to use the formula when you are forced to calculate these values. But if you are given, then it's just a continuation. So that is the idea there. So this is another way that you could have calculated your percentage regulation. All right, so we have got our percentage regulation. Let me just write it here. Our percentage regulation, I'm going to use the first one that I obtained from the formula. It depends with which one are you going to use as you are continuing with your calculations, which is 8,915%. This is what we got. All right, so let's check because normally they will need you maybe to continue from there unless it's a typical exam. After this, you'll be done, guys. You know that, okay, I have those values. So also do not forget the sign of phi in case maybe you need that because they are talking about a leading. There's something later on there. But okay, let's see. See, they need you to calculate the voltage, which is the secondary terminal voltage. Secondary terminal voltage corresponding to the voltage regulation calculated above correspond after, that is our V2 new. Remember, I talked about this. After the regulation, they can have the condition where you need to calculate the new voltage according to the regulation that just occurred. So we saw that from our formula that the new voltage at the secondary terminal can be obtained from the original V2 that we had into 1 minus per unit regulation, where per unit regulation is representing the decimal part of the percentage. So how do I obtain the decimal part? I must divide percentage regulation by what? 100. Remember, guys, this per unit regulation is simply percentage regulation over what? Over 100 divided. So meaning say our per unit regulation is this percentage regulation already given as 8,915. You divide it by 100. This was going to give us a per unit regulation. If you divide by 100, it was going to be 0,08915 as it is. That's per unit regulation from this. With this per unit regulation, a decimal, use it to calculate now the new voltage, which is V2 original. And our original is there. That's our V2, the original voltage that you had on our information, into 1 minus per unit regulation, which is as a decimal 0,08915. This was going to give us the new voltage as of the secondary terminal side, and that was going to be 218,604 volts. Okay, so that is the conditions there. And considering, comparing this with the V2 original, the original one that we had here, 240, and the new one that we are seeing, we can see that our V2 new is less. Our V2 new here that we are seeing, we can see that it is less than this V2 original that we had. And I said, if it is like that, when it is less, it is a lagging power factor. And truly, this was from a lagging power factor. Remember, you're calculating this from what? A 0,8 lagging power factor. So that it must correspond to that. Give us the same information to tell us that you're in the right direction. So that was our voltage from there. And now they want you to calculate, this time they need you to calculate and D. This is what you need. On D, they want you to calculate the secondary terminal voltage if this transformer supplies a load operating at a power factor of 0,8 leading. So if you check this question on D and the one that we had on C, the secondary terminal is the same, secondary terminal voltage, but it was corresponding to the voltage regulation that we calculated above. So this one, it must correspond to this voltage regulation at this leading power factor. So we need per unit regulation again, meaning to say we are going to need percentage regulation first before attempting this question. So we saw the application of that formula, guys. You can use the formula, the one that I used in the first part, or you can use the short one. So I'm just gonna use the second formula since we used the first one, guys, and you saw that how it can be used. So that is the D. For us to obtain this V2 new, as we are given, we are going to need V2 original into what? 1 minus per unit regulation. The per unit regulation that is at what? At this 0.8 leading power factor. At 0.8 leading power factor. Remember the previous case, it was 0.8 lagging. So there, guys, we're not gonna, there's nothing that is much, there's nothing much that has changed. The cos of phi, which is our power factor, is still the 0.8. Meaning to say the sine of phi is still the 0.6, the one that we calculated before. Nothing has changed. The only part that has changed is the leading, which will affect our formula as we calculate what? Percentage regulation. So on your formulas, remember there are two formulas for percentage regulation. So I'm not going to explain both this time. I'm just going to work with this one, the shorter one, this one. I'm just going to work with this. But remember, your percentage regulation can be calculated from this formula. We're going to go back to that formula. Use it as it was before, but this time you use a negative because it's a what? It's a leading power factor. So the same with this one that I'm going to use here for percentage regulation, I'm going to use this one with a what? A negative. So it's up to you, like which condition are you going to consider, guys? You can even use that that one that we had, this one. It's up to you. But like I said, guys, I'm just going to be short because of time. I'm going to use this. You have similar answers. So just a little bit difference that we just have there. Okay. So percentage regulation from this formula is given. Remember, it's percentage resistance cos of phi plus percentage reactance, the sine of phi. Or you can use other formula depending with your understanding. So percentage resistance, we already have these values. Remember, it was 4%. Our percentage resistance here, it was 4%. So that's 4 times the cos, which is our power factor, the 0.8 plus percentage reactance. Remember, our percentage reactance is 9.5 times the sine of phi, which is 0.6. So this was going to give us a percentage regulation, and that was going to be negative 2.5%. But as we do understand on the calculation, we need per unit regulation. And per unit regulation, it simply means what? Percentage regulation over 100. So you take this answer, you divide it by what? By 100%. So it was going to be negative 0.025. This is per unit regulation that you use here. Per unit regulation. So that was going to give us V2 new from that per unit regulation. So V2 new can be calculated. So you see how they want you to link up the formulas. Back to our mathematics. This subject is one that applies your mathematics, a lot of it, compared with other engineering subjects that we talk about, electrotechnics. Okay, anyways, let's substitute 240 into what? 1 minus the per unit regulation, which we got as a negative. So it's a negative as it is. Write it as it is. So a minus and a minus will give us what? A plus. Yeah, will give us a plus. So you're going to multiply everything. Then you're going to get your V2 new, which is the new voltage now at the terminal side of the secondary. And that was going to be 246 volts, which is bigger than what we had before, to show us that it's a leading power factor truly. That is how it was supposed to be like. So these are the questions that they'll give you. So it's gonna depend with exam questions. These are just your typical examples from your textbooks. So you can see that with this information, you can now relate it, answering question papers and see how questions are given as you are to deal with your percentage regulation. This part, you do not just focus on that, only think along calculating of these from what you have done before up to the equivalent values when you're dealing with the method of referring. They can even relate back to those ones, provided that these values are given. But you must have equivalent values first. With those equivalent values, percentage regulation can be calculated. Is it that you are referring from the primary or you are referring to the secondary? You can still have same answers. Or if you are given percentage values, then the formula can be used instead. This sorry for that, guys. Provided that I have percentage values, percentage leakage reactance. So we shall see from our question papers in our next class, as we are gonna have other questions we will see as time moves on, to relate with our question papers. Till we meet again.